All right, so this is going to be the last one for the respiratory system, and we're going to be talking about gas exchange. So as this pulmonary artery comes and meets up at the capillaries on the alveoli, you see that the oxygen concentration in here is really low. It's about 40. When you look at carbon dioxide, it's about 46. When you look at the alveoli, it's held at about a constant of 102 oxygen and about 40 carbon dioxide. And so as this stuff comes, they're going to want to get an equilibrium, right? You're going to have diffusion, and so it's always reaching an equilibrium. And so as this comes, oxygen leaves from this higher region and goes lower. Carbon dioxide goes from this higher region to go lower. And then up here higher, you're going to have oxygen around 150 and carbon dioxide around 0. And so that's going to cause this new balance arising down here. So as that comes out, some's going to come down. When this goes up, some's going to come out. And then when you end up over here in the veins, you're going to see you've reached that equilibrium of 102 and 40, give or take. There's this thing called ventilation-perfusion coupling. So when you have poor ventilation, so when you have low O2 coming in, if we look right here, so if our O2 is low up here, it's going to be low down here, right? That's going to cause this bronchiole to actually constrict. And so if O2 is not making it down here, something is not working, right? And at the same time, that's going to cause these arteries to constrict. And so if something is not working higher up and you're not getting enough oxygen, you don't want to be sending blood to an area that isn't getting a lot of oxygen, because then you're not going to get that diffusion that you want. And so your body just kind of shunts off the blood to that region, shunts off any more air going to that region. And so it's like, this one's trash. Bring it back once it comes back. I don't know. And you have the opposite. So if you're having a lot of oxygen going to one region, those bronchioles can dilate, they can open up, and also those blood vessels will dilate and open up. So you have an area that's working really well. You want to use that area so you can get the most blood to it and not to these areas that aren't working very well. So yeah, with high ventilation, you see the dilation and the dilation of the arterioles as well. So looking at our alveoli, in pneumonia, we see that you start getting fluid and even blood in these alveolar walls. That is going to cause these walls to thicken because of edema, of swelling. And with that extra fluid, we know that blood or that oxygen doesn't diffuse very well through fluids. And so it's going to decrease the amount of oxygen that is diffusing across. It's going to have to go further because of the swelling of these cells. And so overall, it's going to decrease the amount of oxygen that you can get to your body and the carbon dioxide that you can get away from your body. Versus your healthy ones, I think if you look at one with emphysema, you'll see a breakdown between these alveolar walls. And so this is decreasing the overall surface area for which you can have diffusion. In talking about diseases, we can talk about COPD, or chronic obstructive pulmonary disease, something like chronic bronchitis. So bronchitis, anytime you see itis, that's talking about inflammation, okay? And so with chronic bronchitis, you're having chronic inflammation in the bronchioles. Stuff that can happen with chronic bronchitis is your goblet cells are going to be making way too much mucus, and also the cilia don't beat, and so you get this mucus that's really thick and not moving. Smoking, if this person was a smoker to cause their chronic bronchitis, paralyzes the cilia so they don't beat. It also kills your macrophages, and then you see that classic smoker's cough. It's really wet, mucousy sounding cough, typically with sputum or this mucus that comes up from these bronchial tracts. Something else you see in smokers is emphysema. So emphysema, your alveolar walls start breaking down, and so you're losing those surfaces for diffusion to take place. It also decreases the elasticity of the lungs. So the lungs, they're really elastic, and so when you breathe in, your lung goes from a small size to a big size. Like you can even see it happen in your chest, right? Like you take a deep breath, and it all fills up. And then when you relax, it squeezes out. What happens with emphysema is you breathe in, you got your sac, but when you breathe out, you don't get that snap back, right? And so with emphysema, it's a lot harder to breathe out. It takes 3 to 4 times energy to breathe out than it normally does with just the snap back. And so with a lot of people who have emphysema, you'll hear them when they're breathing out going, like pushing really hard to force out that air because the elasticity in their lungs isn't there anymore. And then, classic picture, healthy lung versus smoker's lung. There's a big difference. Look at how this lung is pulled away from the heart. You're getting a little bit of collapse from those areas that aren't getting enough oxygen. So smoking and lung cancer, they go pretty hand in hand. But there's a lot of other things that can cause lung cancer, like mesothelioma. You get like asbestos that can cause different types of lung cancer. We're going to focus on 3: squamous cell carcinoma, adenosine carcinoma, and small cell carcinoma. When you're looking at squamous cell carcinoma, you'll see that pseudostratified columnar starts becoming stratified squamous. We talked about it up in the nose, how when it starts getting drier, you'll have that change going from pseudostratified to stratified squamous. When you have a bunch of particles, like smoke particles, dust particles, entering your lungs, that pseudostratified will start changing to stratified because there's a signal that says you need to protect this area of your body. And so they start making stratified instead. And if it continues, that stratified can actually invade other tissues if it mutates, causing bleeding lesions. So when you cough, there'll be blood. Also, you'll see swirled masses of keratin. And so in here, typical cells, squamous cells all over the place. The next one is your adenocarcinoma. This one's pretty common. You typically see it in the mucus glands of the lamina propria, and it turns malignant about 10 to 20% of the time. So looking in here, you can see the lumen of this gland in the lamina is just filled with mucus. That's a pretty good sign that you have this adenocarcinoma. And the last and most dangerous is your small cell carcinoma. When you look at it, these cells kind of look like little oat grains, so it doesn't look like your normal cells. So these would be cells that you would typically expect to find in a lung, and all these little bitty ones are atypical. This normally starts happening in the main bronchi, but it spreads really quickly. And so looking up here at this slide, you can see these are all your typical cells. These are all the small cells. They're really packed in there tight. Their nucleus takes up most of the cell. There's not a lot of cytoplasm. They don't have a nucleoli, which is a region that makes RNA. And so, you can tell that this does not look like this because this is all cancerous. All right, so smoking, lung cancer accounts for what some of the most numerous cancer deaths are 3 types: squamous, adeno, small. 90% start in the mucous membranes of the bronchi. The tumor, if the tumor happens in the bronchi, it can block off that bronchiole. And if that happens, you can have atelectasis, or the collapse of a lung. Here, you can see the atelectic lung, where this bronchi got blocked, and then that lung collapsed and is now looking much denser. Like, it looks almost as dark as a bone, right? Versus your normal lung looks very hollow and filled. A lot of times this comes with coughing of blood, mucus, sputum. About 18% survive 5 years. And as you go out from there, that number just keeps dropping. On that bright note, we are done with the respiratory system. Don't smoke.